This is Mathletics 7 in the shape unit. It's called rotations coordinate plane. So here's what's happening in this one. It says identify the rotation of the red figure to the blue figure. So it started as the red figure and then it's rotated around this center point we call the origin to become the blue figure where it is. So this point has moved all the way down to this point. This point has moved all the way down to here. This point stayed the same and this one's shifted over. So essentially it's rotated around, not shifted, rotated around that center point as if the red was now where the blue is. So is this 90 degree, 180 degree, what is it? Well, what we can do is pick one of the points. So I'm going to pick this one right on this line and it's shifted down or rotated down to be down here. It's straight below, okay? And if we drew a line from that point to the center origin where it's rotating around and then straight down here, we'd realize that that angle between our axes here is 90 degrees, which tells me it's a 90 degree rotation. If it had rotated all the way around to the other side, so this point, the blue point became over here on 10, then it would be 180. But it didn't go quite that far. It went half the way that far. Now it's red turning to blue, red rotating to blue, which now we need to determine is it clockwise or counterclockwise. And I know you guys use a lot of digital clocks, but you know what an analog clock is, the one with the hands. A clock, they tick this way, whereas counterclockwise is the other way. So clockwise is the negative way, counterclockwise is the positive way. And in this case, you just have to say clockwise or counterclockwise. So it is going from red to blue, which is the opposite of what a clock normally does. So it would be counterclockwise. I'm not sure, there might be some that are blue to red, that kind of thing, but in this case it's red to blue. So this time it's shifting around, or sorry, rotating around. It's going around this way. It's going from red to blue, and it's going the same way as a clock, and it's only 90 degrees. If it's only moving one quadrant over, so from quadrant 1 to quadrant 4, it's a 90 degree. If it's moving quadrant 1, 4 to 3, so 2 over, then it would be a 180 degree. That's another way to check this. So in this case, it's just a 90 degree clockwise. This one is 180 degrees. Notice that it's flipped to the absolute opposite side. It's spun all the way around. This would also be a reflection, but it's a rotation because that's what I think they're saying. So it's 180. Why? Because it's completely to the opposite side of that center point. And here's another one. It moves one quadrant over. Remember, these areas are the quadrants. They move from one to another, red to blue. It just moved one over. So it's not 180. It's a 90 degree rotation. And it moved from this way. It moved the same way as a clock's hands go. So it's a 90 degree clockwise. One last one. This is 180 degrees. It's moved one, not the next quadrant over, but 2 over. Either way, it doesn't matter which way you go. This way, this way. It doesn't matter if you go clockwise or counterclockwise, you're going to end up in the same spot with a 180 degree rotation.